proud to tell you that PMA is India's premier management association, established in year 1977 as an independent trust and public organization. It was founded by all the time great industrialist, late Padma Bhushan S.L. Kirloskarji, late Mr. V.S. Vaidyaji, late Mr. C.S. Kirloskarji, late Dr. N.A. Kalyani, and late Mr. C.V. Zog. PMA is a center of excellence in the domain of management that empowers the individuals and enterprises to excel in their endeavor. PMA is engaged in the research work, creation and distribution of knowledge, enhancement of skills, and application of best practices in management. Importantly, PMA has its own library and training hall facilities centrally located at Shivajinagar in Pune. PMA focuses on providing a wide range of services to improve the standards of management practices in India. You all know that we organize conferences, seminars, relevant training programs, lectures, discussion meetings, where experiences are shared. We also sponsor specific research projects and forming study groups. Under the PMA umbrella, recently we have formed more than 12 centers of excellence, that is COEs, which are the verticals dedicated for specific domains such as innovation and emerging technologies, academics, sales and marketing, finance, business excellence, quality, skill development and entrepreneurship, IT, human resource, and so on. Center of Excellence for Innovation and Emerging Technologies, that is COE-IET, has been formed in year 2020. That was last year. At COE-IET, we have 15 members who are top-notch experts in India or internationally in various domains. At COE-IET, we have further sub-verticals such as artificial intelligence, IoT, predictive analytics, electric vehicles and transportation, security and surveillance, blockchain, fintech, AR, virtual reality, robotics and RPA, digital medicine and wellness, cloud computing, and so on. All these experts are volunteering to join hands together at PMA for the vision and mission of PMA for the benefit of individuals and enterprises in all possible ways. As part of the initiative and efforts, we are presenting today's webinar, which is the second session in the series of 2, delivered by the expert, Mr. Dinesh Doshi. The first session was delivered by him on August 30th, and we received an excellent response to that. Mr. Doshi is with us again today. While I welcome you all, I now request Dr. Satish Chinchorkar, Deputy Director at COE-IET, who is also the moderator for today's session, to introduce the speaker, Mr. Doshi. Over to you, Dr.
It is my privilege to welcome all these office bearers today. With us, we do have
interesting topic, predictive analysis. Let me share something about PMA activities development. Today only we have signed a MOU with Institute of Management and Entrepreneurship Development, IMED, the Management Institute of Bharati Vidyapit. We have a tie-up now. We will be taking care of various aspects of placements as well as incubation of their students. I think last meeting I had announced about the tie-up with Vitti Corporation about the various activities in the field of artificial intelligence. So these activities are taking place now. We will be shortly announcing various programs under that, some paid programs and some pre-sessions to update you about the technology. Similarly, I think you'll remember we have received through our partner Aspire Knowledge an order for incubation center development, that is conceptualization plus actual implementation of incubation center at Kolhapur Smart City Corporation. So this is also one of the activities. So in short, what I want to highlight is there are n number of activities going on at PN. Take this opportunity to all of you to join hands. We generally call it as a joy of giving back to the society. So please enjoy joy of giving back to the society, back to the youngsters, back to the young professionals through your experience and expertise.
This is the second session. Dilip Joshi, he worked extensively in the predictive analysis right now. He is engaged in some overseas project also in the Malaysian country. He is doing some project. As I introduced earlier also, he got 28 plus years of experience after completing his post-graduation from the Walchand College of Engineering in the product design development and the manufacturing operations. He is instrumental for the digital transformation, and he has done his master's in the production engineering. So I will not take much time, and I wanted to hand over to now Dinesh Joshi for today's session, and I'm very sure he will make today's session also very fruitful, and people will find it is the value-added session. So over to you.
Pradeep ji, Dilip ji, and Satish ji for the introduction and opportunity given for discussing with the colleagues on the predictive analytics field. So what we'll do, I will just start with the presentation. It is visible now? Okay, good. Thank you. So basically today's session is the second session on predictive analytics for business. And it is more focused onto the applications. Last time when we started discussing on the predictive analytics for business, I said that it is basically for the smart businesses where the companies would like to improve their processes, business processes, by making them transparent, agile, and even more optimized to reap more benefits out of this predictive analytics. So for the benefit of the attendee as well as other people also, let us have a recap of the session number 1. So quickly, maybe in another 5 minutes or 5-6 minutes, I will go through the slides which we have discussed last time, and then we'll have the demo session. This time what I thought was that instead of discussing only on the theoretical parts, what are the steps that we discussed on predictive analytics, let us see it actually we using some software tool that will give more idea for the the attendees. So last time we discussed that we started with the operation excellence, and we said that Six Sigma is basically the method used to improve the capability of the business processes. And we also discussed on the Six Sigma aspects and its relationship with the data-driven stages. We said how the DMAC helps over there. And we also saw that the operational data, which is captured from various sources on the in the industry, that operational data, how it flows to the intelligence and how these process intelligences can be aggregated together to make the data analysis as a valuable subset of Six Sigma. So we also discussed last time that when the Six Sigma is the means to improve, data analytics is the method to improve. At the same time, we also discussed last time on the basic concepts of the data analysis, data analytics, and the data sciences. And we said that data analysis is a subset of analytics, and analytics is a subset of data science, where in data analytics, we process the past data, and that past data exploration is done for the future predictions. So the past data as well as the current data is always used for the data analytics purpose. That is what we discussed last time, and we also discussed the importance of the data analytics for the industry, saying that for the business owners or the decision makers in the leadership role, the people can make use of the data analytics for their business, how their business is progressing, to find out, or to identify the areas of attentions, to make the informed decisions, because we also discussed that predictive analytics is all about the informed decisions and various ways of doing the businesses efficiently by optimizing the operation performances and so on and so forth. So With that, this is the slide on which I will focus more in this session. Also, I will spend maybe 2 minutes on this slide. And we discussed there has to be certain journey to reach to the predictive analytics phase or even to any of the data analytics phase. So the complete journey is divided onto some 6 stages. And we say that unless and until the organization invests into the digitalization and captures the data digitally from various sources like sensors or the MES system or whatsoever over there, once that data extraction is there available, then that extracted data is captured at the centralized location for the database building in the network. So that can be the protocols, that can be data logs, various databases, and so on and so forth. And once that data is available into the database, then the actual analytics starts. So what the people should do with that database? The first and the foremost thing is that the people tends to visualize the current status as well as the historians. Now, when we talk about the current status and the historians of the data, it is nothing but the descriptive analytics. And this descriptive analytics answers the question of what is currently happening in my business. So when we are going to find out such kind of questions on what is currently happening on my business, then that is the descriptive analytics. Now, when we know that, or when the person knows that what is happening in my business, the next logical question is that why something is happening in the business. Again, that is based on the current data. Why currently something is happening in the business? That becomes the case of diagnostic analysis, where various correlations of the data, the anomaly detection, pattern recognitions, trends, that root cause analysis is done to identify on why something is happening into the business. Till this phase, everything is based on the historian data or the current data. But the next phase is obviously the question will come as what will happen with my business? That is the future prediction. So currently I may be good or I may be bad, but what will happen after some time? On the time series, what will happen? So that is the predictive analytics, and the company would like to have the predictive capability by usage of certain ML algorithms, certain technologies over there for the future prediction. That becomes the predictive capability. And beyond predictive capability, there is the prescriptive analytics, which takes which talks about the recommendation ability within the organization using some AI technologies, and that leads to some self-optimizing processes. So basically, the prescriptive analytics talks about the strategy outcomes at a broad level. So we will be discussing more currently onto the predictive analytics. So last time what we discussed was that the basic flow of the predictive analytics. We said that this is the statistical method where the historical data is used in the predictive algorithms in various ways, and the new data, that is the current data, real-time data, can also flow into the model, and the model works with that data and does some kind of predictions over there. So this happens through the data modeling. This is the basic structure of the predictive analytics. And we also discussed about, just to make the concepts clear, we discussed about the shopping mall example in the real life scenario, and how we can build various expected variables like the target variables and the historical data and what is the prediction model and all those things. So this case study we discussed over there, and we said that there are certain steps into the predictive analytics project. Now, in this predictive analytics project, we are going to make use of these steps in today's discussions, where there is the first case. The first point is selection of the target variable, then getting the historical data, then how we split that data, then how we build the model, how we validate that model. All these things will sequentially we will discuss in today's model. And last time we also discussed about the beneficiaries, few industrial applications of the predictive analytics. And for the today's session, I thought of selecting only one application, which is the marketing analytics, and how predictive analytics can be used for the marketing analytics perspective, that kind of the example I thought I will take over here. So for the case study on the marketing analytics case study, that is what we'll be discussing it in our today's session. So if you see the objective of the use case, I will firstly let me explain you the objective. The objective is that certain company would like to have the marketing campaign, and in that marketing campaign for a certain group of people within the region, and those certain group of people are having the income either which is less than 50,000 or above 50,000. Now the company would like to target the people whose income is less than 50,000. Now, what is the task? The task is that based on the input data, we need to identify how many people a marketing campaign should reach to. Now, obviously, here the understanding is that for the marketing campaign, if we try to reach to 100% of the people, the cost will be higher. So what will be the optimized marketing cost or market planning cost, so that we should reach to the people, but still we will be able to connect to the certain number of people, certain percentage of the people who are having income less than 50,000. So that is the use case. We'll explain it with the variables also, how this case can be developed. But for this case, basically, when we said that our job is to find out, these targeted people, from where it will come. So it should come from the census data. So census data is the right choice for, from authenticity point of view, I'm saying. It is the right kind of data set that can be used to accomplish the task. So a census data was made available that consists of the details about the individuals and various parameters over there. And it has the discrete variable of income with two values, which is above 50K and which is less than 50K. Now let us see how we can address this task through the predictive analytics capabilities. Now for the predictive analytics capabilities, what we need to do is we need to use the suitable ML algorithms, and we will be following certain steps over here. So we will be following the steps, like we'll be creating the target variable, we'll be importing the data, we'll be exploring the data, partitioning, building, all such kind of things we are going to do over here. So what I thought was that actually just talking it onto the theoretical part, let us have the actual demonstration of the the case study. Before going further, let us just have a brief the statistics about the data that we'll be using, that census data. So whenever we'll be importing the data file, we'll see all such kind of data over there. But from statistic point of view, just let me tell you that there are some 16,000 records which are available. And if we see how many records are there for less than 50,000 K income, those are 76%. And for more than 50K, those are around some 23-24% kind of thing. Now, here we will be, reframing our problem statement. Now, the problem statement will be, we have been given a task to find out how much percentage of total population should be contacted through marketing campaign, so that the organization can reach to the desired percentage of population having income less than 50,000. So now the problem statement has completely been reframed. Now what we will be doing is that our target variable will be the income less than 50K, but we will be concentrating on to the percentage of total population which should be contacted. Now with this scenario, let us see how we can achieve this using some software tools. So here I have used some software tool, from Alter Engineering, that is Knowledge Studio. Let us see, that demonstration. I will just stop sharing the PPT on project with some name. And with that project, what we will be doing is that for this task, we will be importing some suitable data file. Now, this data file, as I told you, is the source data file, and we will be importing that source data file as the census data file. Now, that is available with me in the Excel format. So I will go and I will just select that census data file. I will say next, and you will see that there will be various field selectors. I can deselect the fields, I can select the field one by one also, or I can select all the fields. Now, all these things, please remember that if you do not use it, if you are not using the software tool, then the Python programming should carry out all these steps. So your Python program should be in a position to capture all these parameters, all these fields over there, and it should be in a position to curate the data also. So that data preparation should also be done. So I will go and I will save this, and once I save this data, the next time I will use all these things to run the data, so that I will have this census data available with me. Now, when I said that we need to have the data profiling, so from this point onwards only, our analytics, it is not a predictive analytics, but the analytics process starts. Because the moment we have all the data with us, then we will go through all that data, and we will have all the statistical information available with us. So if we can see that, in this overview report, the information that displays certain dataset structure, and in this data set structure, along with the univariate statistics. The univariate statistics is something like minimum, maximum values, or mean and the standard deviation, something like that. Even the software program can also be done to find out certain basic analytics, the points also, like say for example cardinality. Now, what is this cardinality? Cardinality is the number which indicates the distinct values available in that particular field. For example, gender. For gender, the gender can be male and female. So there are only two distinct values available over there. Income. So it means that if there are less number of the distinct values, the cardinality number will be less, and that is good for our further analysis. So it talks about how the data spread is there, and how we are going to have the predictions using this data set. If we go to the data, then again, similarly, we can have the data seen over here. You can select some of the columns and all those things, and you will have all the data available with us. So here you can see that we are having all these 1600 16281 records, which you can see it over here as an Excel file. Now, once this data is also available with us, and we can just doing the profiling of the data, another thing is that we can have the segmentation viewer. Now, what happens in the segmentation viewer is that we can visualize the distribution of these independent variables with that of the under each category of the segmentation variable. Now, the segmentation variable, or the variable which is of our interest, is the income, because our problem statement says that we need to reach to the people who are having income less than 50K. So our segmentation variable, data segmentation, is done on the basis of income. The moment I will do it on the basis of income, other independent parameters can be seen over here. Now again, as I told you, I can either take all the parameters, or I can select one by one parameters. So I can just take all the parameters and I will say, okay, that segmentation viewer will give me the graphical plot. Now this graphical plot will be of the the independent variables like age, work class, education, status, gender, whatsoever, those are there, against the dependent variable. And the dependent variable was income. Again, for income, the cardinality was 2. So there are two things for the income, and I can actually map, I can predict for the age and the income group of minus 50K, how the distribution of the data will be, so on and so forth. So here, what important point we also need to see is that about the data, Why we are doing all this data profiling is that we are just going to verify whether the data which is available is good enough to build the model and predict the results. If the data quality is not so good, then obviously the results will be bad. So there are certain checks in between which we need to consider while working on the predictive analytics models. So here the important point or the important checkpoint is entropy explained. Now, when we talk about the entropy explained, what does it mean? Is that this entropy variance is basically it talks about how much information that the DV value is contained. So our DV value, that is our dependent variable value income, and the the node data set, that is our field name age, has the entropy. So minimum is the entropy value. It means that higher information about the income is there with the age. So the correlation in between the age and the income can be well established over here. The work class and the income can be very well established over here. So this gives us, so in short, minimum value of entropy explained is always better for us. There are also other things also like the cross tables where we can have, income versus age or income versus, the gender, such kind of graphs, we can see it over here. And we can predict that maximum is this. So the people who are into the group of income group of less than 50K, those are from the age of those are from the age of 17 to 24, and also the income which are the gender which are male over here. Similarly, we can have the income and the all these correlations over there. Just a moment, I will just switch off my mobile. Yeah. Sorry. So once we do all these things, and then we also have the character analysis over here. So again, we have the income as a parameter and all these independent parameters we can consider, and we can have the graph also, like how the DV income versus the age graph, which we have seen it something in segment viewer kind of thing. So it means that for the income, the age group of 39 to 46 will have more income. Whenever it will be from above 50K. For less than 50K, the age group of 17 to 24 will have more income. So it means that what kind of the population that we will be focusing or we can focus, because at the end of the day our decision will also be based on how much percentage of the people we should reach out of this complete population who are having the income less than 50K kind of thing. So once we do all such kind of things, we come back, and then once we are having the data with us, we do the next thing is basically the partitioning of that data. Last time also we saw that the data partitioning is nothing but making the training data set and the test data set. So here I will make the training data over here, and for the training data with the hold on rule, what we discussed last time, various rules over there, we have allocated 70%, while for the test data we will be allocating some 30% of the data, and will update, and all these records of 16,000 will available into the partition. And once we run the partition, that complete records will be bifurcated into the training data set and the test data set. Now the moment I will go to a training data set, it will be exactly like our census data set, where we will have the records now which are available for the training, and then we can again start working on similarly we need to do the data profiling over here also. All the data we should have the segmentation viewer also with the income and with the independent variables over there, so that we will take care of, and then again we'll see the entropy explained is not exceeding, it is not going to 1. Then we will have the cross tables also with the income and age and so on and so forth. and some characteristic analysis where we have the income as my characteristic variable and all other independent variables selected over here, and the graph is available. Now, once that has been done, so what does it mean? Our data partitioning is now complete with, the holdout method of 70-30 ratio. We can even change that ratio to 80-20 and all those things. The main purpose of making this training data set is to train my model for the predictive capability building. Now, here we are going to have, the building of the ML model. Now, there are so many models which are available from the statistical background. So which we will be using here will be the decision tree for various reasons. Because this decision tree is the most suitable, model in the current scenario where we will be using the decision rules for inferring which class we are, targeting. So for the decision tree, we'll be using the data set of the training model. And once we go to the decision tree, here I will give the name something like, say, income decision tree, because this is my income decision tree of my training. And I have the dependent variable, which I will select it as the income, and I will go ahead. I will do this clustering and all those things over there, and I will select income as a variable over there. I will say automatically grow this, and I will save it. And the next time, whenever I will be working on that, I will be, just ensuring that income is my dependent variable, and I will be selecting the income, and I will run this. Now, what it will do, it will just give me the, the understanding that for the income class of less than 50K and 50K, out of 1100, the data set, these many data sets, 76% of the people are below 50K, 23% are above 50K. It means that my data has sufficient value to predict the income group of the people from income group of 50K. So such kind of, checkpoints, intermediate checkpoints, we can do it using the data models. Now this data model is built from the data set. So the next step is obviously we will be validating this model, because this model now needs to be validated for, just to understand how it behaves. Now for this validation, I will take the ML model over here. Now whatever is happening, this is just from the, from the software side. So you consider it as the software things. So it has the ML model as well as the data set model, and we will run this data validation. And here we will again have some income decision tree over there, where we'll consider the income and some prediction values will be there. We can select the parameters as we need, and we will run this model over here. Now, once I run this model decision tree, I get some validation report. Now, if you see the validation report, that I have run it onto the training data. Now, last time, if you remember, we discussed a lot about the confusion matrix. Now, confusion matrix is the tool that will decide on the accuracy of the model, or it will tell us how accurately we have built this model. Now, when I said how accurately we have built this model, in that while creating the model, while creating the decision tree, various things were there like cluster and all those things. So I just selected the, whatever was available over there by default. But you can, the data scientist can play with that, and he can even make the model more mature related to the, the accuracy. So with that, what we discussed over here was that in the predicted for 50K, these values are for the the model had predicted that there were 8,098 the models which will be, or data sets which will be less than 50K, and actually those were less than 50K. Here the model predicted that there will be 1281 data points which will be above 50K, and actually those were above 50K. But here in these two things, the model have made certain errors, that the model had predicted that 589 data sets will be above 50K, but actually those were less than 50K. The same case was here for the more than 50K income value also. Now, depending on this confusion matrix, if you see, there are total records of 11,000 in the training data set. Now, correctly predicted records is nothing but sum of this 8098 plus 1281, which are correctly predicted. We last time we call it as the true positive and true negative. So these are the true positive, true negative are the records which are correctly predicted, while wrongly predicted are the false positive and false negative kind of things. So here, if you calculate the efficiency, that is 9,300 divided by 11,000, that gives me the prediction efficiency of 82.92%. It means that my model, which I have built, using the training data set, has the efficiency of 82.29%. Now, the same thing, what we have done it using the training data set. Similarly, the model validation has to be done on the test data set, because last time we saw that now we have taught the model on how to behave, and we have also checked that whatever we have taught the model, 82% of the times it is behaving properly. So let us validate the model for the test data set also. Now again, for that validation, you will need one ML model and you will need the data set. Now using the ML model and the data set, we will run all these things and we'll see that I'm not going to change anything over here. So income we will change, predictability is obviously available over there. Again, we can select the parameters and we can say save over here. Next time I will say run. Now, the moment I will run this thing, I will have another validation report on the test data. Similar validation report on the test data. Now in the test data, I had that total records of 4,884. Now what has happened is that whatever the software or the model, predictive model has learned in this complete phase of training, now the same algorithm, it is going to use it on the test data. Now it is not using the training data set, but using the test data set to predict the validation of the training test data sets. So again, here the confusion matrix is there. As we have seen last time also, there were total records, and here the percent time that is on the training data set, the efficiency of the model that it exhibited was 82.3%, and now it is 83%. Now it is nearer to each other. What does it mean? It means that unless until it is nearer to each other, our model is not correctly built. But because both the values from training and testing data sets are more or less matching, because again this is the educated guess, so more or less matching, our data model is near perfection for our outcome prediction. It means that now our model is ready to deploy for the regular conditions, for the real-time data that will be available. Now I have this income decision tree from the test data also, where I have tested. Now this is again a model which is built, and we understand that this is a good model. But at the same time, we also need to analyze this model for evaluating the performance of the complete ML model. Now how I should do that? I have the model analyzer, which will evaluate the model performance, and this model performance is basically evaluated for the dependent variable. Now the dependent variable that we selected last time as a target variable was the income, and the people having the income group which is less than 50K. So such kind of things, and we would like to understand the probability of those people. Now all those, the problem statements, the variables, what we actually formulated while reframing our task, those things you need to consider over here. If it is not income, if it is something different, you can select various parameters over here. If the income of more than 50K, that also can be done using the same thing. And then we'll save this, and the next time we'll run all these things. Now, when I say that run, so after running this model analyzer, what we get? We get an opportunity to see various statistical values now of the dependent variable. In our case, it is the income, which is a statistical value with the condition set by the predicted value. Now, normally, if you see, there are various graphs now available over here. So there is a cumulative graph, cumulative lift graph, you can say. It represents the percentage of target and the percentage of population. What does it mean? It represents the variable of our interest. Now, what was our variable of interest? Variable of interest was percentage of population to be targeted. So we would like to see how many percentage of the population we should target so that we can reach to the people, good amount of people, or a targeted amount of people who are having the income less than 50K kind of thing. Now, how we can do that? Let us go to the data grid, and you can see over here. Now, as a marketing, the leadership in marketing, I know that I had, the total population of 16,000 people. From that population, I had 12,000 people who are having, the income less than 50K. Now, to how much percentage of the people I should, target? Say, for example, if I say that this is 12,000, and as a marketing person, I will say that even though I will reach to say 8,000 people, means say 70% of the population, even though I will reach to them, still that is okay for me, because again the cost will come in picture. Now in that case, I will see here that if I would like to reach to say 70% of the people, it means that on the graph you can see that the simplest thing is that I need to reach out to the 83% of the population. So unless until I reach to the 83% of the population, I cannot reach to the 70% of the people whose income is less than 50K. If I would like to go to, say, for example, 60% of the 60% of the people whose income is less than 50K, then in that case, I need not to touch base upon to a large volume of the population. Just nearby 74% of the population, if I touch base, it gives me the prediction that I can have the 60% of the people touch base upon having the income less than 50K. So such kind of predictive analytics can be done, which will be very useful in making the decisions over there. Again, as we discussed a lot last time, this predictive analytics is all about an educated guess. It doesn't guarantee you that if you reach to 73.85% of the people, then your 60% of the population can be addressed. Because if you see here the graph, the trend of the graphs, then every time you can see this is little bit changing over here. It is upward or downward. This is because your model has to be very smooth and it has to be learned, fine-tuned more and more, which your data analysts will be able to do. So such kind of tasks like how much percentage of the total population should be contacted can be addressed using the predictive analytics. And as I told you, there will be still various opportunities to refine this decision tree model for better prediction accuracies, and the data scientists are the right people who can further fine-tune this model. With that, I will just stop sharing this particular demonstration, and I would like to go back to the presentation just for the last part of the presentation. And last time we discussed that in PMA we are having the initiative of predictive analytics. Just a moment, let me see that. Now, yes. So from the use cases perspective, what kind of use cases should be targeted? So case studies. So these are some of the ideas or some of the hints that I would like to produce in front of all of you, that these are the areas in which the predictive analytics has been applied, and there are various roles of predictive analytics in such kind of fields. So if we would really like to focus on taking the predictive analytics to the industries, these are the areas. The first area is obviously remaining useful life of the tool. So RUL analysis of the tool is very important when we are getting all the the data from the sensors and the devices, the process parameters in real time, and also the exceptions. That is important. Human inspection data. So when, even though we have all the process parameters in place, still there was a problem. So at the problem, what was the process parameters data? So such kind of, the correlation, we can build it using the machine learning algorithms to proactively alert for approaching the time of tool replacement. And then in that case, my time of tool replacement will be the DV. The dependent variable on the independent variables of the process parameters. So such kind of things we can definitely do it over here. Another thing is asset failure predictions. So historical and real-time data from, again, the sensors through ML models can accurately flag the potential failures of the critical components. For example, the bearing failures that can be predicted very well using the predictive analytics methodologies. Price optimization is another thing which people normally call it as the market basket analysis. Normally, this is in the retail kind of thing where that the person, when he comes and purchases certain product, along with that he also purchases other products. So what is that, the trend in that particular region or the trend of the particular people over there, that can be captured, that data can be captured, and the organizations using the predictive analytics tools can optimize, their even the warranty offers they can optimize by considering the competition, price points, customer preferences, the discounting structure. All those things can be done using the predictive analytics tools. Another thing is anomaly detection in the production systems. So making use of the shop floor data, maybe from MES systems, from PLCs, SCADA systems, sensors data, whatsoever, your unusual behaviors or the patterns can be very well recognized in the earlier stages by these ML models. How the trend is going, kind of thing. Please remember that anomaly, when I say about the anomaly detection, it is not the threshold based alerting. Like something has gone wrong, so I have got the alert. That is again comes into the descriptive kind of thing, which we saw the earlier in our earlier journey phase. We saw that what is happening currently in my business, that is the descriptive analytics, or even why it is happening in my business is also diagnostic analysis. But we are talking more about what is likely to happen in future in my business. That is important, that we can very well capture onto the production systems. Supply chain risk management is another area where the long, complicated, unpredictable supply chains pose the risk for the manufacturers, and ML models can use for the they can use the data from various agencies like the government, shipping boards, the shipping agencies, and manufacturers. So many people can give the data, and using that data, they can prepare a supply chain delay and develop their contingency plan. Because again, more and more data available with them, with the more and more failures available with them, they can fine tune that model, and they can accurately predict the supply chain delays in the complete risk management process. Demand forecasting, supply forecasting is just the the offshoot of this supply chain risk management process that is having a very well applications into the ML models. And the last thing is obviously the HR analytics, where the data-driven method, they have the HR functions have their own KPIs, and based on the, HR matrices. So how well they capture the quality of the data, how well they capture the exceptions. Based on that, the models can analyze their KPI score versus their targets, the organizational target. It is the same thing which we have seen it into the demonstration over here. and based on that predictions, the alerts on the factors which are adversely affecting onto the KPI achievements can be available from the ML models. So with that, I will just make the last statement that predictive analytics, this is what we discussed last time also. Like predictive analytics is very easy to understand, but it is not that easy to apply in the real life situations, because it needs a combined efforts of lot many people, even the data analysts, the scientists, the statistical people, the programmers, the dashboarding people, and more importantly, the domain knowledge people. The group of all these people can definitely work together for the predictive analytics. So with this, I will just stop sharing my presentation. And again, once again, thank you very much for the opportunity that has been given. We will definitely, address some of the questions. But if anybody is having any question over there, you can reach through PMA from the PMA website, or you can send me the mail, and we as a PMA and myself, we can, the